Hello everyone. Now we are discuss about the subject CE 8395 Strength of Material for Mechanical Engineers. So Unit 3 Torsion. The course outcome of in this unit is after successful completion of the student should be able to illustrate the stress and deformation of circular structure and helical structure subjected to torsion. The knowledge level of in this unit is K2. We have discussed about the helical spring problem. So formula used for closed coil helical springs. That is the formula we have using the problem solving. So first formula shear stress. Shear stress thus equal to 8 WD divided by small d power cube or 16 WR divided by small d cube. Unit is Newton per millimeter square. Unit is Newton per millimeter square. Where T D is diameter of the wire mm. Capital D is mean coil diameter. Unit is mm. W axial load. Unit is Newton. Second formula deflection del is equal to 8 W d cube n divided by C d raised 4 small d raised 4 or another formula 64 W r cube n divided by C small d raised to 4 unit is mm, where n is number of coil, small n is number of coil, C is modulus of rigidity, unit is Newton per millimeter square. Next, third formula strain energy stored subjected to axial load. Subjected to axial load. So U is equal to thou square divided by 4C into volume of the spring. Unit is Newton millimeter. Unit is Newton millimeter. Then volume of the spring is equal to L into area. Volume of the spring formula L into area. So we got write the formula for thou square divided by 4C into by dn into area by 4 small d square by 4 small t square. Next fourth formula strain energy stored subjected to axial twisting couple. Strain energy stored subjected to axial twisting couple. So U is equal to sigma b whole power square divided by 8E into volume of the spring. 8E into volume of the spring. So the sigma b is equal to bending stress. Unit is Newton per millimeter square. E is equal to Young's modulus. That is unit is also Newton per millimeter square. So fifth formula stiffness of the spring. K is equal to W divided by del. Unit is Newton per mm. So another one formula for stiffness K is equal to C d raised to 4 divided by 64 r cube n. 64 r cube n. Next problem. Here closed coil helical spring made out of 8 mm diameter wire has 18 coils. Has 18 coils. Each coil is of 80 mm mean diameter. If the maximum allowable stress in the spring is 140 megapascal, determine the allowable load on the spring, elongation of the spring and stiffness of the spring. Take C is equal to 82 kilonewton per millimeter square. So the given data, the spring made out of 8 mm diameter wire. So the wire diameter is 8 mm, 18 coils. So N is equal to 18 coils. Each coil is of 80 mm mean diameter. So mean diameter capital D is 80 mm. Then allowable shear stress of the spring is 140 megapascal. Take C, modulus of rigidity. C is equal to 82 kilonewton per millimeter square. So we can write the given data. Small d is equal to 8 mm. Number of coil N is equal to 18. Mean coil diameter capital D is equal to 80 mm. Allowable shear stress 140 megapascal. We got converted to Newton per millimeter square. That is the conversion 140 Newton per millimeter square. Then modulus of rigidity 82 kilonewton per millimeter square. That is also converted to Newton per millimeter square. 82 into 10 power 3 Newton per millimeter square. So to find W, del, K stiffness. So we got that three are the find values. So next we got write the formula. Shear stress on the closed helical coil spring formula thus equal to 8 WD divided by D cube. 8 WD divided by D cube. So you apply all the given values. The value is 140. 8 into W is unknown. 80 divided by D cube. So D is 8. 8 cube. So we got simplify that values. We got the W value. So W is equal to 351.86 Newton. 351.86 Newton. That is the answer of W. Next we got find out the deflection of the spring. Next we got find out the deflection of the spring. Del is equal to 8 W D cube N divided by C D raised to 4. 8 W capital D raised cube N divided by C small d raised 4. That is a formula. So we apply all the given values and calculated values. 8 into 351.86 into 80 raised 3 into 18 divided by 82 into 10 raised 3 into 8 raised 4. So we have simplifying that values. We got the answer of deflection equal to 77.24 mm. 77.24 mm. Next we have calculate the stiffness of the spring. K is equal to W divided by del. So we apply all the calculated values of W and del. 351.86 divided by 77.24. So 4.55 Newton per millimeter. That is the value of stiffness. So the result allowable load on the spring W is equal to 351.86 Newton. Deflection of the spring del is equal to 77.24 millimeter. Stiffness of the spring K is equal to 4.55 Newton per millimeter. So stiffness K is equal to 4.55 Newton per millimeter. So we have calculated all the fine values. That is the result. Next problem. That is another one problem. Yes, safety valve which is placed on the pressure vessel has 120 mm diameter is used to blow off at a pressure of 1.23 Newton per millimeter square cage. It is held by the closed coiled compression spring of circular steel bar. The mean diameter is 180 mm and initial compression is 20 mm. Find the diameter of the steel bar and the number of turns necessary if the shear stress allowable is 90 Newton per millimeter square. Take C is equal to 0.82 into 10 power 5 Newton per millimeter square. So once again I will read the problem. A safety valve which is placed on a pressure vessel has 120 mm diameter. Pressure vessel 120 mm diameter is used to blow off a pressure of 1.23. Pressure is given 1.23 Newton per millimeter square cage. It is held by a closed coil compression spring of circular steel bar. So the spring is closed coil spring. The mean diameter is 180 mm. So mean coil diameter is 180 mm and initial compression is 20 mm. That is the del. Initial compression means that is a deflection. Del 20 mm. Find the diameter of the steel bar and the number of turns necessary if the shear stress allowable. So shear stress 90 Newton per millimeter square. Take C is equal to 0.82 into 10 power 5 Newton per millimeter square. So the given data, diameter of the pressure vessel D is equal to small d 120 mm, pressure P is equal to 1.23 Newton per millimeter square, mean diameter capital D is equal to 180 mm, initial compression del is equal to 20 mm, then shear stress thou is equal to 90 Newton per millimeter square, modulus of rigidity C is equal to 0.82 into 10 power 5 Newton per millimeter square. To find diameter of the steel bar, then number of turns required. So that are the find values. So that is you have find out diameter of steel bar and number of turns required, small d and small n. Then solution, total force on the valve W is equal to area of valve into pressure. Area of valve into pressure. So we have apply the area of valve by 4 into d square. So the diameter is given 120 square into pressure 1.23. So the W is equal to 13.9 into 10 power 3 Newton. So we have calculate the force. W is equal to 13.9 into 10 power 3 Newton. So we have apply the shear stress formula. Thou is equal to 8 WD divided by d cube. 8 WD divided by d cube. So all the values are given. Small d is unknown. So we have find out the small d. So you can apply all the given values. 9d is equal to 8 into 13.9 into 10 power 3 into 180 divided by into small d cube. So small d is equal to 41.37 mm. So we know that. Next we have calculate the deflection. So deflection formula del is equal to 8 W capital D cube N divided by C small d raised 4. So we apply all the given values. 20 deflection value is 20, then 8 into 13.9 into 10 power 3 into 180 power cube into n divided by 0.82 into 10 power 5 into 41.37 whole power 4. So we have simplify that values, we got the answer of n. So number of coil n is equal to 7.4. So you can round the value of 8 number of coils. So we have calculate the number of coils n is equal to 8. So the result, diameter of the wire, spring wire D is equal to 41.378 mm. Then number of the turns required n is equal to 8. That is the answer. The reference textbook, R.K. Bensal, Strength of Materials, Lakshmi Publication. Then U.C. Jindal, Strength of Materials, ACN Books Private Limited. Thanks for watching my video. Thank you.